let's start off elimination. So let's start off with this example. 2x plus 6y equals 15, and x equals 2y. Write this down, please. Do you see how that second equation is not in the same form that the first equation is in? The first equation is in ax plus by equals c form. What do we call that? Standard form. The first equation is in standard form. But the second equation is not in standard form yet, is it? So I want you to start by rearranging. Let's subtract 2y so we can put that second equation in the right order. So when I subtract 2y, I have x minus 2y equals 0. I have nothing left on the right side. Go ahead and bring down that first equation. I'm going to write it on the bottom here. It doesn't matter if it's on top or bottom. So I've got 2x plus 6y equals 15. So these are the two equations that I'm now using. We talked about elimination the last time we had class, and we said in order for elimination to work, we have to have opposite terms. 2x and negative 2x, or 6y and negative 6y. Do I currently have opposite terms?
No.
I don't. So here's where the multiplication comes into play. I want to multiply one of these equations by some number so that I have opposite terms. What value could I multiply by?
3.
Which equation are you thinking times 3?
Negative 2y times 3.
The first equation?
Yeah.
I agree, that would work. If we multiply by 3 in the first equation, what variable would that potentially eliminate for us?
Y.
The y's. What if I wanted to eliminate the x's? What could I multiply by?
2.
Negative 2. Which equation, Bradley?
Top one.
That's right. We could also multiply that top equation by negative 2. And it doesn't matter which route we take, we should still get the same answer. I'm going to go with what Colby suggested since he suggested it first. He says multiply the top equation by 3. Thank you. Okay, so would you go ahead and put parentheses around your top equation and put times 3 on the outside. I'd like for you to go ahead and multiply that top equation by 3. So x times 3 is 3x. Negative 2y times 3, negative 6y. And 0 times 3 is 0. I'm now going to add these two equations together. These two right here are the two equations I'm using. I'm adding these two together. When I add the x's, 2x plus 3x, I get 5x. When I add the y's, what's 6y plus a negative 6y? 6y minus 6y. They're going to cancel. And 15 plus 0 is 15. We should be able to solve this equation. How would you solve? Divide by 5. And 15 divided by 5 is 3. All right, so I'm going to have an ordered pair answer. It's going to be 3, comma, something. To find that y value, what am I going to do with 3? Plug it in. Does it matter what equation? No, it doesn't matter. As long as your equation has an x and a y. I'm going to use this one right here, the second one. I'm going to put 3 in for x. I'm going to take this 3 and I'm going to put it in for x. So 3 equals 2y. How would you get y by itself? How would you solve? Thank you. Divide by 2. And 3 divided by 2 is 1.5. I'm okay with a terminating decimal like 1.5. So 3, comma, 1.5. Did you remember to write your answers in ordered pair? Please put parentheses around it. How about this one? 2x plus 2y equals 3. And x minus 4y equals negative 1. In order for elimination to work, we have to have opposite terms. Do I currently have opposite terms? Remember, opposite terms are where they would cancel out. If I add 2x and negative 2x, those would cancel out. If I had 4y and negative 4y, Those would cancel out. Do I have that in this situation? I don't. So that's where the multiplication comes in. What could I multiply by to make opposite terms? Which, okay, the first equation by 2. What if I want to eliminate the x's? Which equation, Bo? Good. Either one of those ways would be fine. I'm going to go with what Bradley said first. He said multiply the top equation by 2. You almost have to be able to think ahead and predict, all right, if I multiply by 2, that's going to give me a positive 4y, which would cancel the y's out. So let's multiply the top equation by 2. So 2 times 2x is 4x, and 2 times 2y, and 2 times 3 is 6. I didn't do anything to the bottom equation, so I'm just going to bring it down. Okay, so if I add the x's together, what do I get? 4x plus x? 4x plus x? 5x. 4y minus 4y? And 6 minus 1? Or 6 plus negative 1? Is 5. We can solve for x by dividing by 5. X equals 1. So I know my ordered pair is going to be 1 comma something. One comma something. Let's put 1 back in. Does it matter what equation? It doesn't. Pick an equation with an x and a y. I'm going to use, let's use the second equation. 1 in for x, I'm going to put it right there. 1 minus 4y equals negative 1. Subtract 1. So negative 4y equals negative 2. Divide by negative 4. What's negative 2 divided by negative 4? 1/2 or 0.5, either one. So 1 comma 0.5. Make sure you write your solution as an ordered pair, 1 comma 0.5 or 1/2. This one's a little bit different. Make sure you get it copied down. 5x minus 3y equals 6, and 2x plus 5y equals negative 10. Do I currently have opposite terms? No. Anybody have a thought as to what we could do to make opposite terms? By what? 3. By 3 on which equation? Bottom one by 3. What do you hold with? 5. You can multiply by something different on the top and bottom. You guys have an idea? Colby?
Multiply the bottom one by 3 and the top one by 5.
Yes, that would work. If we because what would that eliminate, Colby?
No.
What would that eliminate?
The y.
Good job. Yes, multiply the bottom one by 3 and the top one by 5. Okay, hang on a second. Colby, can you tell us, how'd you come up with this? This is right, it's exactly what I would do. What was your thought process?
Just looking in like the same numbers that each one can fit into.
Yes.
Like, 3 can go into 15 and 5 can go in 15.
Right, 3 and 5 both go into 15, don't they?
Yep.
And they already have opposite signs, like one's negative and one's positive in those positions, so I agree totally with what Colby did. Could we have eliminated the x's here? Yes. So think ahead, what number do 5 and 2 go into? They both go into 10, right? So one's going to have to be a positive 10, the other's going to have to be a negative 10, doesn't matter which is which. How could I get positive 10 right here? Multiply by 2. What could I do to get negative 10 down here? Times negative 5. And either one of those ways will work. But let's go with what Colby suggested first. So I'm going to multiply by 5. I have 25x minus 15y equals 30. In the second equation, I'm going to multiply by 3. So I have 6x plus 15y equals negative 30. Now let's add these two equations together. When I add 25 plus 6, I get 31. When I add the y's, those are going to cancel. And 30 plus negative 30 is 0. How do I solve this equation now? Divide by 31. And 0 divided by 31 is 0. So it's going to be 0 comma something. How are we going to find that y coordinate? Plug it back in. Put 0 in for x. Doesn't matter which equation?
Nope.
No.
No. Let's use that first one. So 2 times 0 plus 5y equals negative 10. 5y equals negative 10. Divide by 5. Y is negative 2. How can we check these answers? Yes, decimals is a good resource, but on a tester quiz you don't have decimals, do you? Plug them in. What does that mean? When we say plug them in, like how can we, I put 0 in for x and obviously negative 2 in for y. Well, how do I know that it's right? Bradley?
When say you put 0, negative 2 in the bottom one, you get 0 for x, and the y would be negative 2. So 5 times negative 2 would be negative 2 equals 10.
Right, so when I put 0 and negative 2 in, it should equal negative 10, right? When I put 0 and negative 2 in here, in the first equation, it should equal 6. Decimals is an excellent resource if you have access to that. If not, just plug it in. Let's do this one. This example, we have a's and b's. Does it matter if they use x's and y's? Or a's and b's? No, we'll just write it in alphabetical order and write our solution. So 6a plus 2b equals 2. And 4a plus 3b equals 8. Okay, we don't currently have opposite terms. Does anybody have a suggestion as to what we could do? Bo?
The top one times 3.
Okay.
And the bottom one times 2.
Get close. Negative 2 would work. Because we want to get one positive and one negative. So I like Bo's suggestion. He says top one by 3 and bottom one by negative 2. Before we do this, what variable will this cause me to cancel out or eliminate? Cause me to eliminate the b's. Could I have eliminated the a's?
Yes.
What number do 4 and 6, looking at the a's, what number do 4 and 6 go into? Could have used 24, what about 12? Could I have used 12? I could have eliminated the a's that way. Alright, so let's go ahead and multiply the top one by 3. I have 18a plus 6b equals 6. In the second equation by negative 2, I have negative 8a minus 6b equals negative 16. Okay, so when I add the a's together, 18a plus a negative 8a,
10A.
10a. What's going to happen to these b's?
Yes, allowed.
And 6 plus negative 16? Negative 10. If I divide by 10, what is a going to be? I'm hoping you guys are starting to see, like, if you have 10a equals negative 10, you know that's going to be negative 1. Okay, hopefully in your head you can know you're going to divide by 10, results in negative 1. How do I find the b value? How do I find the b value? Plug it back in. Does it matter which equation?
No.
Nope. I'm going to substitute into, let's use the second equation. So 4 times negative 1 plus 3b equals 8. So negative 4 plus 3b is 8. Add 4. So 3b equals 12. You guys should be able to solve an equation at this point. Okay, we'll kind of quickly through that. Whoops. So b is 4. Negative 1, comma, 4. This will probably be our last one. 2x plus 2y equals 31. And 2y equals negative 2x plus 7. Okay, so clearly the second equation is not in the right order, correct? We're going to have to do a little bit of rearranging. how would you rearrange that second equation?
Plus 2x.
Could I, that's an option, that's one option, but I'm thinking ahead. What if I had subtracted 2y and I subtracted 7? Will that also work? Okay, so let me just explain what I just went through there. Bo says add 2x, so that's definitely an option, we can do it that way. My suggestion was, let's subtract 2y and subtract 7. Is that legal? Yeah, let's try it that way. I think you'll see what I mean. Let's subtract 2y. And I'm going to move 7 over to the other side. When I do that, I have negative 7. Those are gone. Those are gone. Equals negative 2x minus 2y. Now, I need to make a switch, don't I? What property says I can flip-flop the right and left sides of the equation? Not reflexive. Reflexive is the same on both sides. First an S.
Symmetrical.
Symmetric. Yes, symmetric. Let's do that switch. I'm just going to use the symmetric property of flip-flop the right and left side. So it's negative 2x minus 2y equals negative 7. The reason I did that is because now don't I already have opposite terms?
Yeah.
I don't have to do anything. I've already got my opposite terms. I'm going to bring down this other equation, this first one. I'm just going to put it below. So 2x plus 2y equals 31. I've got opposite terms, don't I? What's going to happen to the x's and the y's?
Both goes up.
They're both going to be canceled. And I've got to put something on that left side. I'm going to put a 0. And negative 7 plus 31? 24?
Yeah.
Is 0 equal to 24?
No.
So then what do we say?
No solution.
From a graphing standpoint, what would this graph look like? There's no
Parallel.
solution. They would be parallel. Our solutions are where the lines intersect, and if they never intersect, they have to be parallel. What if it had been 0 equals 0? Do you remember what we said on a situation like that? We would say infinite solutions. And not all the numbers, but infinite solutions. Alright, so today we are solving using elimination. What do we have going on tomorrow in here? Quiz. We're going to solve by graphing, substitution, and elimination. And on your quiz, I'm assessing each individual method. So there's going to be a section where you're solving by graphing, a section where you're using substitution, and a section where you're using elimination. Today's homework is out of your textbook. If you would please turn to page 358.
Here's where the other answers come from.
Numbers 7 through 18.